Welcome to NCKHUB Consulting and Training. As part of our Java 8 playlist, in this video, we will be discussing the implementations of predefined functional interfaces that were introduced as part of Java 8. So, as part of Java 8, there are many functional interfaces that were introduced, but the basic functional interfaces are predicate, consumer, supplier, and then the function. So there are still more predefined functional interfaces that are available, but all those were like extensions of these four functional interfaces. Let us say int predicate, double predicate, long predicate, by predicate, and similar way, double consumer, int consumer, long consumer, by consumer, and similar way when it comes to the function, by function, and unary operator and binary operator. So there are many extensions for those four basic functional interfaces. So as part of this video, we will be seeing the implementations of the functional interfaces that are listed over here. We will be seeing the implementations for the four basic functional interfaces and few extensions of those functional interfaces. Now let us discuss one by one. We will start with predicate functional interface. So, as discussed in our previous video, for a functional interface, we will have only single abstract method and we will be able to provide the implementation for that directly using the lambda expression. So, in case of predicate, what is the single abstract method that is available? The method name is test. And how many inputs it will be able to accept? Only one particular input argument. And what is the return type for a test method? It's a Boolean. So whenever you have to provide an implementation for a predicate, you need to make sure that it will be processing only for one particular input argument and the return type you will be getting is a predicate. Let us see an example for the predicate now. So here is the example for the predicate. And I have created a class here inside the main method, and here I'm trying to create an object for the predicate. And as discussed, test is the abstract method here, and for that particular method using the lambda expression, I'm trying to provide the implementation. So here one particular input argument is being passed, and I'm trying to check whether that particular input, whatever I pass, is greater than -10 and less than 10. And I will be getting a Boolean value as the output because for test method, the return type is a Boolean. So this is the way we can create an implementation for the predicate. And one of the extensions for a predicate is the by predicate. If you see here, by predicate, this is same as a predicate, but it has two input parameters. Whereas for predicate, it accepts only one parameter as input, but for by predicate, it accepts two inputs as a parameter. But the return type will be same for both the cases. It is Boolean, true or false. Now let us see the example for a by predicate. For a by predicate, here I am passing two integer values as an input, and my implementation will do some operation on those two, and finally I will be getting a Boolean value as the output. So this is the way we can do the implementation for a by predicate. Let me try to execute this particular example. So in both the cases, let me change this to predicate. Now let me try to execute the example. So for predicate, I'm getting the value as return type as true, and for by predicate, I'm getting the return value as true. Let me change the value here. I'll change the value to 13. Now let me try to execute this program. So now the value is false here. And for the second one, it is still true because I did not change any value. And the reason for the false here is 13 is not in the range of values that I am checking for. And that's the reason I got a false. And this is the implementation that we can use for the predicate and its extension by predicate. Now let us go to the another functional interface, which is nothing but consumer. So what is the abstract method that we have in consumer? It is accept. And this accept method also will be taking single input as an single input argument, and then it will not be returning any return value. So consumer itself is like it will we will consume the method, and that method will do certain operation. That's it. It will not give anything return to us. So for any scenario where we can pass something to the method and that particular method can implement something, in those cases we will be using the consumer. From a consumer related functional interface, we will not be expecting anything back as a return value. And let us see the examples for the consumer. So here is an example for consumer. What I'm trying to do is here I'm trying to pass a string value to the consumer, and that consumer implementation will try to calculate the length of the string and then print. So we are just trying to print it to the console, but I'm not expecting it to return back to me. So it will accept the inputs, it will do some operations, and then it will end it up. It will not do anything, it will not return us back anything. And one of the extension for the consumer is by consumer, and this by consumer is same as the consumer, but the only difference is the number of input parameters. For consumer it will be only one input parameter, and for by consumer it will be two input parameters. So by consumer abstract method implementation will accept two input values, but the same way it will not return anything. Now let us see the example for that as well. So for the by consumer, I am passing two string values. What it does is it will try to concatenate both the strings, and it will try to print the output to the console. Now let me try to execute this example. So for the first one, I'm just trying to print the length of the string, and that particular length of the string is 7. And for the by consumer, I'm passing two strings as an input, and that particular implementation is concatenating the two strings that I am passing as an input, and here is the output I have got. So for consumer it will accept the input if it is a consumer single input, and it is a by consumer multiple inputs, multiple in the sense two inputs. It will accept the inputs, it will do the processing, but it will not return anything back. What we can do is we can add it to a collection object, we can add it to a some other already predefined object or whatever way it is, or we can print the output to the console, but it will not return back to the calling method or anywhere. This is for the consumer. And the next interface that we have in our discussion is the supplier interface. So for a supplier functional interface, what is the single abstract method that we have is get. So this get method will not be taking any input. Instead, it will execute some logic and it will give you the response. It means that supplier interface, the method inside the supplier interface, whenever we are trying to provide the implementation, we need to understand that it will not take anything from you. Instead, it will execute some logic and then give it back to you. That's the difference between supplier and consumer. Consumer will accept the input, does some logic, it will not give back. But whereas supplier will not accept any inputs, but does some logic processing and then give it back to us. So what is the example use case for the supplier? Let us go to the examples. So the best example we can see is the OTP generation. So everybody has very familiar with OTPs. So how do we generate OTPs? So we will be executing a logic inside the get method by using the implementation with lambda expression. And for generating the OTPs, we need not give any inputs. We can just give call the method generate OTP, and that itself will generate OTPs for us. So this is a very good example for the supplier use case. So let us see this particular example which I am showing here. I am trying to see to generate a OTP with 5 digits, and I provided the logic here, and I am trying to generate two OTPs. I'm trying to call the get method of the supplier multiple times. That means two times. Let me see by running the example. So if you see, the first time I got the OTP as 15302, and for the second call I got the OTP as 26011. Let me try to execute again. So this will randomly change because this is a dynamic logic. So now if you see the output, the OTP is different from the earlier ones. So supplier is the best example use case for the OTP generation part. Now the other functional interface that we have in our list is function. So what is the single abstract method for the functional interface? Apply is the method that is the abstract method inside the functional interface, and this apply method will take one particular argument as an input, and then it will do some processing, and then it will return the value as well. So if you observe all the things except the predicate, the other three, consumer, supplier, and predicate function, consumer will accept the input but does processing, and then it will not return anything, whereas supplier will not take the input but executes the logic and give us something. But whereas function is the combination of both the supplier and consumer. Function will take the input, does some execution, and then give it back to us. So based on the use cases that we come across, we need to identify or pick one of these functional interfaces and implement the abstract methods in our business logic. Now let us see the examples for the functions. So the examples for the function here is, I'm providing one particular input as a string, and I asked the as part of implementation, I'm trying to calculate the length of this string. Okay, after calculating the length of the string, it will automatically return the value from the where I am calling the method. Let us say here I am calling the function.apply method, and inside that I am passing a string. So what I am expecting is the length of the string to be returned from this particular implementation to here. And for a function also, we have an extension called by function, and the difference between function and by function is same case like earlier, consumer and predicate. It will by function also will accept the two input parameters, and it will return the response. So if you see in the by function here, for a by function, I'm passing two strings as inputs, and the output will be integer. But whereas in a function, I'll be passing only single input, which is a string, and I'll be getting the output as an integer. If you observe very carefully here, the input data types and output data types are not same, are different. Okay, now let us focus more on the execution part. So for a by function, what I'm trying to do the implementation is I'm passing two strings, and the implementation of that apply method is first of all, both the strings has to be concatenated, and then the length has to be calculated. Now let me execute this program. See, for a functional interface example, so I got the length of the string as 26, and for a by function, I got the length of the string as 10. So if you observe here function and by function, for a function, it will accept only single input, and it will return the response. And for by function, it will accept two inputs, and it will return the response. Whereas the data types between the input and output are different, completely different. Why I am stressing more on the data types here is, we have one more functionality here, unary operator and binary operator. Let us see what is unary operator and binary operator. Unary operator can be used when both input type and response type are same. Response type in the sense return type are same instead of function. So if you see the function here, while trying to implement, what I have done is I took the input type as string and the return type as an integer. Let us say both the cases string is the data type, then I need not use function. I can go for unary operator. Similarly, for binary operator, both the input types and return type are same, we can use the binary operator instead of by function. Let us say here for by function, I have used the input types as string and output type as integer. Let us say if I have all the three as strings only, I need not go for a by function, and I can use the binary operator. Let me show the examples of unary operator and binary operator. So here is a unary operator. Here I took a list of integer values, and I have five integers, and I try to provide the implementation using the unary operator. So if you see the syntax here, there is a slight difference. Since the data type is same for input and output, we need to mention only once. We need not repeat the data type here. So if you see the function example, here you are mentioning a string and integer, input and output, because the data types are different. But whereas here you can have only single one. You need not have multiple things. Okay, so you need not mention separately input and output. Since both are same, you can have only one, and you are declaring an object for unary operator, and you are providing the implementation here. And the calling part is still the same, simply because unary operator is an extension of the function. You still have the same single abstract method apply. And when you call this particular implementation will be executed, and you will be getting the value here. Similar way for binary operator, I have taken a map object, and inside the map, I have the key value pairs. Okay, I have added three elements inside the map with key value pairs, and I created a binary operator. Similar way here also, I have declared only once. I did not do it three times because by function will take two inputs and one output, total three, right? But here only once we have written. So that's the difference between binary operator and bifunction. So what I'm trying to do here is I'm passing two inputs, and that particular input, it will just concatenate and then return the value. So for each, I'm applying for the map object, and both key and value I'm passing as inputs to that map object for each method, and then that will in turn give me the concatenated string here while I call the apply method, which was for the binary operator. Okay. If I try to execute this particular program, see, for the first unary operator, it was implemented for each for all the elements inside the list, and we were able to see the response. Similar way for map object as well. When we applied for each and every element inside the map, we were able to see the response. So the concatenated string key and values were concatenated here, and we were getting the final response. So this is the over a high level idea on overall high level idea on how can we use or implement functional interfaces in a programmatic approach. This is a very basic level of implementation to get some understanding on how the abstract methods can be provided the implementations. And while we discuss more on streams, which is a very important concept in Java 8, and as part of that streams, we will be dealing more on the collection objects, and we will be discussing various collection objects like list, map, and other collection objects as well. As part of that, we will be using all these functional interfaces in combination of these streams. And that will give us the very deeper understanding on all the use cases that we have for these functional interfaces. But to have a final understanding, predicate can be used in the scenarios where we need to have the conditional checks, and consumer can be used where we give the input to a particular method, but we do not expect anything back. And supplier can be used where you cannot give any input to the method, but it does some logic it itself and then provide us the response back whenever we make a call to it. And whereas the function will take the input, does some processing, and then give us back the output. Based on the behaviors and the requirements, we need to opt to the functional interfaces accordingly. That's all for this video. Thanks for watching.